I'm here at the CERN neutrino platform, where scientists and engineers are building and testing prototypes for a new experiment called DUNE. But what does the acronym DUNE stand for?
The correct answer is B, the Deep Underground Neutrino Experiment. DUNE is an international experiment with physicists from more than 30 countries, and it will have 2 detectors at 2 locations, at Fermilab and at SURF, and it will try to uncover some of the secrets of very mysterious particles known as neutrinos.
So all the way in Batavia, Illinois, we have our friends at the Fermi National Accelerator Laboratory, America's premier particle physics lab. Here's your first question. What big fundamental question does DUNE hope to answer?
The correct answer is A, why matter won over antimatter in the Big Bang. So you can think of the Big Bang like this giant explosion. And in that, we created equal amounts of matter and antimatter. And antimatter, you can think of the opposite of matter, like its mirror image. So when the two of them meet, they annihilate, nothing's left. But you know that in the everything that we have, me, you, table, is all made out of matter. There isn't any antimatter. So this is one of the big mysteries we have in physics, is why is everything made out of matter? With DUNE, we can make beams of matter neutrinos and beams of antimatter neutrinos, and we can study their properties and see whether or not this will get us to probe a little bit more about whether or not neutrinos can help us answer this really fundamental question about where did all the antimatter go?
All right, so now let's head over to South Dakota, where we have the Sanford Underground Research Facilities, one of the few dedicated underground physics labs. So Fermilab is going to be sending a beam of neutrinos from kind of around outside Chicago all the way to South Dakota. That's going to be 800 miles or around 1,300 kilometers. Which brings us to our next question. How do the neutrinos actually travel from Fermilab to SURF?
The correct answer is C, through the Earth. We heard earlier neutrinos are not really stopped by a light year of lead, so you know the 800 miles of rock and through the Earth is not really stopping them. And that's also the reason why we need these really large detectors to actually capture a few of these neutrinos eventually down here at the lab.
Where are we right now?
Right now we are inside of ProtoDUNE. That is one of the prototypes for the DUNE experiment. That is a long baseline neutrino experiment that will be built in America.
How big is this prototype?
This prototype is pretty big. In fact, it's one of the biggest prototypes ever built for an experiment. It measures around 10 meters of height times 10 meters of side for the base. And it hosts up to around 1 kiloton of liquid argon.
And how big would the actual DUNE experiment be?
So DUNE will consist in 4 modules, and each one of those modules will be more than 20 times the size of this prototype. So it will be, yeah, pretty big inside.